Alright, let's determine the velocity and acceleration at t is equal to 2 for the position function s of t is equal to t squared minus 2 times t squared plus 2. So we need to understand that the velocity function, v of t, or the velocity after t units of time, we can use seconds. V of t is the first derivative of the position function s prime of t, right? So in this case, what we could do here is we can actually look at the derivative one of two ways. Because this actually kind of looks like a plus b times a minus b, it would make it a lot easier for us to kind of expand this out in the template of a squared minus b squared. So if we do expand it out in that format, you would actually get t to the power 4 minus 4. Now, what I want to do here is I want to utilize power rule just to kind of practice some of these differentiation rules. So if I'm utilizing the power rule, you can see that you'll basically do the derivative with respect to dt, the rate of change of time. I'm going to do the first derivative of the first term to the left, so t squared minus 2 times t squared plus 2 plus the derivative of the right factor, t squared plus 2 times t squared minus 2. Okay, and this is going to give me 2t times t squared plus 2 plus 2t times t squared minus 2. And then if I expand this out, you get 2t cubed plus 4t plus 2t cubed minus 4t. And you can notice here that if you combine the like terms, 4t and negative 4t, you're basically going to get 0. And then the 2t cubed plus 2t cubed is going to give you 4t cubed. Okay, so the first derivative is 4t cubed, right? And you can actually notice that if you looked at the derivative, if you expanded it, you would actually get the same thing, right? If I do s prime of t, you get d dt, t to the power 4 minus dt of 4, and you're basically going to get 4t cubed, and this is going to be 0. Okay, so this does save you a lot of time, but I just wanted to kind of employ product rule. At the end of the day, it gives you to the same result. One is just faster than the other. Using this notion, this is our velocity function. We're going to figure out the acceleration function. Okay, now they want you to find the velocity and acceleration at t is equal to 2. So while we already have our velocity function, v of t is equal to 4t cubed, let's find the velocity at t is equal to 2 seconds. So I'm going to do v of 2, which is going to give me 2 cubed, which is 4 times 8, which is 32. Okay, so basically the velocity at 2 seconds is basically 32 meters per second. Okay, now if we want to find the acceleration function, acceleration describes the rate of change of velocity. It is the derivative of 4t cubed, because we know that acceleration is the first derivative of the velocity function and the second derivative of the position function. So if I am looking for my acceleration function, I do the derivative of 4t cubed, which is going to give me 12t squared. Okay, so this is my acceleration function. And now that I have my acceleration function, I want to figure out what my acceleration is at t is equal to 2 seconds. So I'm going to do a of 2, which is going to give me 12 times 2 squared, which is 12 times 4, which is 48 meters per second squared. Okay, so therefore my acceleration at t is equal to 2 seconds is 48 meters per second squared. Okay, and that is my velocity and acceleration at t is equal to 2 seconds.